Thank you for watching my videos. Please like and share my videos with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We now discuss the solution of a problem that appeared in the question paper CSIR National Eligibility Test held in the month of July 2024. This question is from the section Linear Algebra and it is related to the concepts of orthogonal complement of a subspace. This question is from the part C, a multiple select question. There can be more than one answer and it carries 4.75 marks. The question ID is 704077. Right. The given question is, consider the real vector space V is equal to R, the field of real numbers, bracket X, where X is indeterminate. It is the vector space of all polynomials with coefficients coming from the real field over the real field. And that vector space is equipped with an inner product. What is that inner product is not mentioned. Therefore, we consider appropriately. Let W be the subspace of V consisting of polynomials of degree at most 2. Let W perpendicular denote the orthogonal complement of W in V. Which of the following statements are true? Option 1. There exists a polynomial P of X belongs to W such that x to the power of 4 minus P of X polynomial belongs to the W perpendicular. Option 2. W perpendicular is a singleton set consisting of 0 alone. Option 3. W and W perpendicular have the same dimension over R. Option 4. W perpendicular is an infinite dimensional vector space over R. Agreed. Let's now discuss the solution of the problem in detail. We have the vector space V given by R bracket X, where X is indeterminate, where R is the field of real numbers. R bracket X denotes the vector space of all polynomials in one indeterminate X with real coefficients, and that is a vector space over R. Obviously, it is the set of all polynomials. Therefore, the dimension of V over R is infinity. We are given V is equipped with an inner product. I have already told you that we will take the inner product appropriately. Now, given W, the subspace of V consisting of polynomials degree less than or equal to 2. It's a subspace and the dimension is 3, which is finite. Right. We have W perpendicular is the orthogonal complement of W in V. By definition, it is the set of all vectors in V which are orthogonal to every vector in W, which is orthogonal to every vector in W. Orthogonality is to be talked about in terms of the inner product. And W perpendicular with this definition is a subspace of V. Right. It is well known that V is the direct sum of the W and the orthogonal complement of W. That is, V is W direct sum with W perpendicular. Right. If we take the dimensions on both sides, dimension of V over R is equal to dimension of W plus dimension of W perpendicular. It is plus. It's plus only. Why? Because the intersection is empty actually. Right. So now dimension of V over R is infinity. Dimension of W is equal to 3 plus dimension of W perpendicular. From this, it follows the dimension of W complement with respect to R is infinity. That means this orthogonal complement of W is of infinite dimensional subspace of V. So we call option 4. Option 4 says W perpendicular is an infinite dimensional vector space over R. Yes, it is true. Therefore, the option 4 is true. Agreed. We call option 3 W and W perpendicular have the same dimension over R. That means the dimension of W complement W perpendicular is equal to dimension of W, but the dimension of W is R. So that means dimension of W perpendicular is 3, which is false because the dimension of W perpendicular is infinity. This is not true. Therefore, option 3 is not true. Option 2, W perpendicular, the orthogonal complement of W, is trivial subspace. That is a subspace containing 0 only. Is it so? No. If it is so, how come the dimension of W perpendicular will be infinity? So this is not possible. So this is not true, since the dimension of W perpendicular over R is infinity. Therefore, option 2 is not true. Is not true. So we have considered options 2, 3, 4. Only one option is true, that is option 4. We move on to the next slide for the further discussion of the remaining option. So that's what we have, and V is equipped with an inner product. The time has come to talk about the inner product. To talk about the inner product, we take two elements in V. P of x, a polynomial, a0x plus a1x, a2x square plus etc. Q of x is b0 plus b1x plus b2x square plus etc. They are the two elements of V. They are the polynomials in one indeterminate x with real coefficients. Agreed. Now then we take the inner product, is the inner product of Px comma Qx is defined as sigma I is equal to 0 to infinity ai bi. Agreed. So it's a matter of checking, so you can check all the properties of the inner product are satisfied. Now W perpendicular, that is the orthogonal complement of W in V, by definition it is a set of all those polynomials coming from R of x, P of x coming from R of x, such that the inner product of Px with Qx is equal to 0 for all polynomials Qx belongs to W. For all Qx, where W is the subspace consisting of all polynomials of degree at most 2. Therefore, the elements of W will be b0 plus b1x plus b2x square, where bi belongs to R, I is equal to 0, 1, 2. Agreed. So Q of x is of this type, P of x is of a0 plus a1x, a2x square. Let's take the inner product. So the inner product is 0 for all Qx belongs to W, means Px is what? Px is a0 plus a1x plus a2x square plus so on and so forth. And Qx is b0 plus b1x plus b2x square. Use this formula, sigma ai bi. Then it will be a0 b0 plus a1 b1 plus a2 b2 is equal to 0. Is equal to 0. And this must be true for each polynomial Qx belongs to W. That means for all values of bi, that is bi belongs to R, I is equal to 0, 1, 2. This is not minus, it is equal to. So, when this is true, for all bi belongs to R, this is true only when A0 is equal to, A1 is equal to, A2 is equal to 0. That means AI is equal to 0, for I is equal to 0, 1, 2, 3. It's not minus, this is equal to 0, 1, 2. So that means in the Px, the constant term and the coefficient of the term containing x and the term containing x square will not be there. That means all those polynomials which will start with a3x cube plus a4x power 4 so on and so forth will be there in the W perpendicular. So a3x cube plus a4x to the power 4 so on and so forth, a3, a4 belongs to R. So those are the polynomials that will be there in the orthogonal complement of W. Agreed. Agreed. Now let us go to the option 1. There exists a polynomial p of x belongs to W such that x power 4 minus p of x must belong to W complement. Agreed. Or W perpendicular. So let us take p of x to be equal to b0. P of x belongs to W, therefore b0 plus b1x plus b2x squared belongs to W, such that x power 4 minus p of x belongs to W perpendicular. That is, x power 4 minus p of x is minus b0 minus b1x minus b2x squared belongs to W complement, W perpendicular. How the elements of W complement are there? They will start with a3x cube a power plus a4x to the power of 4 so on and so forth. And this to belong to W complement, there should not be constant term and x term, x squared term. So this belongs to W complement, it is given. So this is possible. This is true if b0 is equal to b1 is equal to b2 is equal to 0, because the orthogonal complement W is of this type. Is of this type. So that means to say, who is p of x? P of x is 0 plus 0 1x, 0x plus 0 x squared. That is the 0 polynomial. Thus, there exists a polynomial p of x is equal to 0, that is 0 plus 0x plus 0x squared, which is a 0 polynomial belongs to W such that x to the power of 4 minus p of x belongs to W perpendicular. Thus, the option 1 is true. Option 1 is true. There's no, summarizing all the options, the answer to this question is option 1 and 4. Option 1 and option 4. That is the detailed discussion of the solution of this problem. It is not that easy problem. It is definitely a difficult problem. I am sure that you have understood the solution of this problem. I thank all my viewers for watching my videos. Please like my videos and share the videos with your family and with your friends and colleagues. If you have not already subscribed my channel, please subscribe my channel. I wish you all the best. Thank you.